So in this video, again, we're gonna review something. So there's nothing particularly new in this video, but what we're gonna do is we're gonna practice multiplying, and you're gonna see. I'm gonna give you specific multiplication problems that are gonna lead you into what comes next. And so if you're like, oh man, I know how to do this, please don't skip it, because what comes next is, I would say, probably the skill that students struggle the most with in the entire year of algebra. So give me a chance to build up into it. Don't skip this video, okay? So what I'm going to do is I'm going to do 3 multiplying problems, and I'm going to make some observations as I go. So here's my first. And what you might notice is that last week's assignment only had things where only had multiplication where it was like x something, and there was none of this. This is new. This 5x here, right? Or this 3x here, that's new, right? In the video that you just saw where we talked about last week's, you'll notice, look, it was just like this. There was only 1x, 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 1x. Right here when I got my answer, 1x, 1x, okay? So this, we're adding on that maybe now there's going to be a coefficient of x, a number being multiplied by x. And you're going to see that that makes factoring harder. It definitely adds a level of difficulty to factoring, okay? So let me just do these 3 multiplying problems, and we'll make some observations about what the patterns are we see, and we'll use those observations to help us factor, kind of like we did the first round, but you're going to see this one's just, it is a little bit trickier, okay? So let's go ahead and multiply. So first I'm going to distribute as 5x, so 5x times x, and 5x times 3 is 5x squared. 5x times 3 is 15x. And now I'm going to distribute the 7. 7 times x and 7 times 3. So that's 7 times x, 7 times 3. I'm going to combine my like terms. I get 5x squared. 15 plus 7 is 22. And there's my answer. Okay, and I'm gonna just hold. I'm not gonna make any observations yet. Let's do one more, and then maybe I'll start with some observations, or maybe I'll even wait till I have all 3. Let's distribute. 3x times x is 3x squared. 3x times 1 is 3x. Negative 1 times x is negative 1x. Negative 1 times 1 is negative 1. Here are my like terms. I'm gonna combine them. I get 3x squared. 3 minus 1 is 2. Minus 1. And there's my answer. Okay, we get 2x times 2x. 2 times 2 is 4. X times x is x squared. 2x times negative 5 is negative 10x. Then 4 times 2x is 8x. And 4 times negative 5 is negative 20. Let me squeeze that on there. Those are my like terms right there. Negative 10 plus 8 is negative 2. Okay, so let's make some observations. Here is what I notice. This term, this first term, it's called the leading term, remember? That's called the leading term. The leading term, which is the term that has x squared attached to it, notice that that is the product of, look, 5 times 1, 5. 3 times 1, 3. 2 times 2, 4. The leading term is the product of the terms with x, right? So this is 5x times 1x, that's 5. 3x times 1x, 3x squared. 2x times 2x, right? So that's the product. Okay, now, this other term, and I, of course, did not bring 2 color pens with me, so I'm just going to do this. This last term, which is the constant term, right? This is called a constant, has no variable attached. The constant term is the product of, look, 7 times 3, negative 1 times 1, 4 times negative 5. And we can see where that comes from, right? Like here, this is where it's from. I multiplied this times this, and I got this. This times this, I got this, right? This times this. This is where they come from. This is the product of the constant terms. The constant terms are the ones without x's, so 7 times 3. These are both constant terms, I get 21. Negative 1 times 1, these are both constant terms, I get negative 1, right? But it's this middle term. It's the middle term is the mystery. And this is the mystery that you're going to see. Oh, sorry, I'm off camera here. It's the middle term that's the mystery that we're going to have to solve when we get to this, this next round of factoring. Okay, so you're going to see that. But for right now, you're going to try a couple problems just like this, where you're just going to multiply and just start to kind of notice some of the patterns. And then we'll get into, okay, how do we work backwards and factor something that looks like this? We're going to be factoring something that looks like this. So we're going to be working from here backwards to an answer that looks like this. Okay, so that's what's coming.